I'm just about 4 feet tall and a little under 62 pounds. I am the world's first social humanoid robot able to recognize faces and basic human emotions.
Imagine a robot that moves so naturally you'd swear it was human. Its every gesture, every step, every subtle shift mimics our own body in motion. Today we're diving into the remarkable world of Protoclone 5.1, a real humanoid robot that is revolutionizing how we think about robotics and automation. Today's video is all about Protoclone 5.1 from Clone Robotics, a breakthrough in biomimetic design that isn't just a piece of sci-fi fantasy, but a tangible, real-life machine. Let's take a closer look at what makes this robot so extraordinary and how it could change the way we live and work. Protoclone 5.1 is engineered to replicate human movement with an unprecedented level of realism. Instead of relying on traditional electric motors or rigid mechanical systems, this robot uses an innovative artificial muscle system called myofibers. These myofibers are synthetic strands that contract and relax much like human muscles. The result? Fluid, natural movements that make the robot appear almost alive. Its body is built on a 3D printed polymer skeleton that mirrors the human skeletal structure with all 206 bones connected by joints that move with the grace and precision of human limbs. At the heart of Protoclone 5, one's movement is a sophisticated network of over 1,000 myofiber muscles. Each of these artificial muscles is designed to contract when a controlled amount of hydraulic or pneumatic pressure is applied. This system not only allows the robot to perform complex actions like gripping, walking, and even mimicking facial expressions, but it also gives it the adaptability to handle delicate tasks. Imagine a robot that can adjust the force of its grip just like you would when picking up an egg versus a heavy object. Complementing its muscular system is an array of advanced sensors. Protoclone 5.1 is fitted with around 500 sensors placed throughout its body, including touch sensors, inertial measurement units, and multiple cameras that act as its eyes. These sensors work together to provide real-time feedback on its position, balance, and the forces acting upon it. This feedback loop enables the robot to constantly fine-tune its movements, much like the human nervous system helps us coordinate our actions without even thinking about them. For instance, when the robot reaches out to pick something up, these sensors help it adjust its grip and ensure it doesn't apply too much or too little force. One of the most impressive aspects of Protoclone 5.1 is its degree of freedom. With over 200 degrees of freedom, this robot can perform a vast range of motions that are incredibly human-like. Degrees of freedom refer to the number of independent movements the robot can make. While many industrial robots might only have 6 or 7 degrees of freedom, Protoclone 5.1's expansive range allows for smooth, natural, and versatile movement patterns. This makes it not only fascinating to watch, but also highly practical for tasks that require nuanced, fine motor skills. The design philosophy behind Protoclone 5.1 is deeply rooted in biomimicry, the art of drawing inspiration from nature to solve human problems. Instead of simply creating a machine that looks vaguely humanoid, Clone Robotics has taken the extra step to study the intricacies of human movement and replicate them. This means every joint, muscle, and even the way it sweats to cool itself is designed with nature in mind. The robot even uses a water-based cooling system that mimics the human process of sweating, allowing it to regulate its temperature effectively during intense operations. This kind of innovation is not just about copying nature, it's about understanding how our own bodies work and translating that into a machine that can function seamlessly in our world. In terms of potential applications, the possibilities with Protoclone 5.1 are vast. One of the most exciting prospects is in the field of domestic assistance. Imagine coming home to find that your Protoclone 5.1 has already started preparing your favorite cup of coffee, tidied up your living space, or even handled some of the more repetitive household tasks. Its natural movements and delicate touch mean it could easily work alongside humans, taking over mundane tasks so we can focus on more creative creative and meaningful pursuits. Beyond the home, Protoclone 5.1 holds promise in industries such as healthcare, manufacturing, and research. In healthcare, a robot that moves with such precision and adaptability could assist with patient care, perform routine tasks, and even help in rehabilitation exercises. In manufacturing, its ability to operate with a human-like dexterity opens up opportunities for tasks that are too dangerous or monotonous for human workers. By taking over repetitive or hazardous jobs, robots like Protoclone 5.1 could allow us to focus on innovation, creativity, and problem-solving. Despite its many strengths, Protoclone 5.1 is still a work in progress. One of the main challenges facing its development is the complexity of bipedal locomotion. Walking on two legs might seem simple to us, but replicating this natural gait in a machine is one of robotics' greatest challenges. Currently, Protoclone 5.1 sometimes requires external support to maintain balance, and its bipedal movements are still being refined to achieve complete autonomy. However, the team at Clone Robotics is actively working on improving its balance and responsiveness. Future iterations of the robot are expected to incorporate even more advanced hydraulic systems and refined control algorithms, which should allow for completely independent, stable walking and even running. Another hurdle is energy efficiency. The advanced hydraulic and pneumatic systems, along with the complex network of myofibers and sensors, require a significant amount of power. This means that while the robot is incredibly capable, its current power consumption limits its operational time. Researchers are exploring ways to optimize energy usage, potentially through more efficient artificial muscles or better battery technology. The goal is to create a robot that can operate autonomously for extended periods without the need for constant recharging or external power sources. Ethical considerations also come into play as humanoid robots, like Protoclone 1, become more integrated into our daily lives. There are ongoing discussions about job displacement, privacy, and how we ensure that these robots are used responsibly. The creators at Clone Robotics emphasize that their goal is not to replace humans, but to enhance our capabilities and improve our quality of life. By taking over tasks that are dangerous, repetitive, or physically demanding, robots like Protoclone 5.1 can allow humans to focus on areas where creativity and empathy are needed most. It's a delicate balance between technological advancement and ethical responsibility, one that the robotics community is actively working to address. Looking ahead, the future of robotics is bright and filled with promise. With continuous improvements in artificial intelligence, materials science, and mechanical design, the next generation of humanoid robots will likely be even more sophisticated. Protoclone 1 is just the beginning, a proof of concept that shows what is possible when we blend nature's design with cutting-edge technology. As these robots evolve, we may see them become common fixtures in our homes, workplaces, and public spaces, working side by side with us in ways that were once only imagined in science fiction. Protoclone 5.1 represents a monumental leap forward in the field of humanoid robotics. It's a real, tangible machine that moves, senses, and interacts with its environment in a way that is strikingly similar to a human. From its revolutionary myofiber muscle system and intricate sensor network to its highly articulated skeleton and advanced cooling mechanism, every aspect of this robot is designed to push the boundaries of what robotics can achieve. While there are still challenges to overcome, such as perfecting bipedal locomotion and reducing energy consumption, the progress made so far is nothing short of astonishing. Protoclone 5.1 is not a figment of science fiction. It's a glimpse into the future of automation and human-robot interaction, one where machines enhance our daily lives by performing tasks with a natural ease and fluidity that was once considered impossible. If you found this exploration into Protoclone 5.1 as fascinating as we did, be sure to hit that like button, share this video with your friends, and subscribe to our channel for more in-depth content on the latest in robotics and technology. Thanks for watching, and stay tuned for our next update on the future of humanoid robots.